Again, trig functions are a little bit more difficult to deal with, but let's write this down. I'm going to write down f prime of theta, and what's that going to be, 11, plus, well, it's going to be more complicated. It's going to be 22 sine theta cosine theta, all right? I'm going to simplify that because I don't want to do the derivative on that guy. So it's still 11, and then I'm going to say 11 times 2 sine theta cosine theta. I want to point out, some identities should be recognizable, and that's one that should be recognizable to you. So I'm going to write this over here. F prime of theta is equal to 11, and this is going to be 11 times the sine of 2 theta. All right, now that's easier for me to deal with. So I'll put F double prime down. Well, derivative of 11 is just a 0. Now it's going to be 11 times the derivative of sine, so it's going to be 11. That's going to be cosine of 2 theta. And then I go to the inside, derivative of the inside would be, derivative of 2 theta would just be 2. So what do you get? You get 22 cosine of 2 theta. All right, that's the second derivative. Now, again, someone says, what's the question? And it took me so long to get that. I don't understand what the question is. The question says, determine the intervals which the function is concave up or concave down. So what I got to do is I got to look at the interval, and the interval goes from 0 to 2, I'm sorry, not 2 pi, to pi. This thing's defined everywhere, by the way. Certainly on the interval, it's defined in the interval. But I'm wondering where it equals 0. And, looking at it, if you look at the cosine curve, let's say cosine of x, becomes 0, at pi over 2. That's 1, and 3 pi over 2. But I have twice theta. And where's that going to occur? Well, it'll be pi over 4. Let me put this over here. And why is that? 2 times pi over 4 is, pi over 2, and cosine 0 at pi over 2. And then it's going to be at 3 pi over 4. Now, someone says, I wonder what 3 pi over 4 is. I'll write this down for you. Right, now if you looked at pi is 4 pi over 4. So, 3 pi over 4 is less than that. I'm going to say over here somewhere. Put my little circles on it. 3 pi over 4. All right? So what I'm going to do now, I got to test this thing out. I'm going to get my eraser out. Erase this business over here. And I'm going to start to analyze the second derivative. And I'll put circles over here. So what do I get over here? I'm going to claim over here this is the second derivative. We'll have to check the key later, by the way, to make sure we got that right. And I got to start taking values over here. And one value I'd pick over here, like you could pick, I'm going to use degree measure, by the way. I'm going to say 30 degrees. Is 30 degrees between 0 and pi over 4? Well, pi over 4 is 45 degrees. All right, let me write that down for you. 3 pi over 4 is 135 degree. And it's going to be 180. All right, so 30 degrees is definitely between 0 and pi over 4. And if you're plugging it in over here, though, and what would you get? 22 times the cosine of 6 degrees. Well, that's definitely positive. Then what I'm going to do is take a test point over here. And again, I'm going to use degree measure. I'm going to say 90 degrees. All right, now if you plug that in, it's going to be cosine of 180. That's going to be a negative. You get a negative number over here. That's concave down. Over here, let's see, I don't know. I pick, let's see, 240. I'm sorry, I didn't mean 240. I'm trying to think of a nice number to pick over there. 45, 150. All right, 150. So 150 is definitely between 135 and 180. So 2 times cosine of 150, it would be 300. And I hope you realize that, you don't have to get the number, but you could get the number. But you're looking at something like this over here. And again, 90, 180, 270, 360. So what I'm looking at, it's definitely positive. Put this over here. Put this down. I could get my eraser out, kind of erase this nonsense over here. I don't need that anymore. Let me make my eraser a little bit smaller. All right, so let's say you forgot what they asked you to do. They said determine the intervals in which the function is concave up or concave down. I can do that now. So it's concave down. I'll put down CD for you. Then we'll check the key, by the way. From pi over 4 to 3 pi over 4. By the way, we're only dealing with the interval they're giving us. Where's the concave up? I'll say CU. It's concave up from 0 to pi over 4. And it's also concave up from 3 pi over 4 to pi. All right, let's get our pen out. I'm going to check the derivative now. Did I get this right? I did. I was wondering, did I get this right? And let's take a look at it. It would be unusual if I got the second right, but not the first one. And that's over here. I did okay. And they also wrote this one over here. Let's see if I wrote that down. Yeah, 11. Yeah, I got right over here. And let's see if we got the intervals right. So point of inflection occurs at pi over 4 and at 3 pi over 4. Yeah, point of inflection. Of course, the concavity changes. Concave up. You know what? I realize they're putting these endpoints on it. And yeah, part of the reason is because these are included. And at 0, it's still positive, by the way, because the cosine. So maybe I should revise this over here, and I'll do that now. Get my eraser out, and I'll revise these things over here. Again, it's still positive there. I really wasn't thinking about that. So let's revise the other one too. At pi, it's still going to be positive. I'll put this over here, and it should be included. All right. So let me take a look, and it might seem like a fine point to you, but it's true. So concave up. Let's see. Oh, you know what? I just made a mistake there. I wasn't even thinking what I was saying. Sorry about that. And I made a mistake. Not thinking, just boxing something. All right, sorry about that. So concave up here. Again, 0 is a positive. That's why I'm shading it in. And 3 pi over 4 to pi is where concave up. And concave down on this interval over here. All right, and we're good to go to the next question. Thank you.